Alright guys, we're going to get started with gravimetric stoichiometry. It's basically chemistry, so equations and reactions using unit analysis, what we had learned last week. Alright, so I'll probably use our s'mores analogy a lot throughout stoichiometry as it's really simple, and now we've all made one. So 1 marshmallow, 1 chocolate, 2 crackers is 1 s'more. So we always have to think about the ratios of how much is required to make the product. Alright, so that's the idea we're going to use a lot. Okay, so gravimetric stoichiometry, or stoichiometry in general, we'll use these 5 steps. All right. The biggest thing to remember is that when we're talking about solids, we're talking about mass. And when we talk about mass, we're always going to use N is equal to little m over big M to find the number of moles. Okay. So the steps as follows. Write out the balanced equation. It's really important to have the balanced equation so that we know the coefficients of each reactant, which will give us the ratios, kind of like our s'mores. I like to organize myself by writing out the known information underneath each reactant or product in the equation, including the molar mass if I'm talking about mass of something. Number 3 is calculate the number of moles of the known chemical. Alright, so using the mass given, we'll use our molar mass calculated, find the number of moles. And then we need to switch. Okay, so we need to switch between moles of one thing to moles of another. And this is where we use our mole ratio. The mole ratio will always be the number of moles of the unknown, alright, over the number of moles of the known. So the known is something we have information about. The unknown is what we're trying to solve for. These numbers come from the coefficients in our balanced chemical equation. So kind of like Avogadro's law, we needed a balanced equation, and N was the coefficients. Okay, now step 5 is convert the moles of the unknown, which we just calculated, to mass. So this sounds really confusing, but let's get started with an example to see if we can solidify that. Okay, so example 1. If you decompose 1 gram of malachite or copper 2 hydroxide copper carbonate, it's all one compound, what mass of copper 2 oxide would be formed using the following reaction? So we know that we're using stoichiometry when we're given information about one compound and asked to solve for information about another compound in the reaction. So it looks like we already have our balanced chemical equation, so that's step 1. Step 2 is to write out what we know about each compound. Okay, so we know that we have a mass of this. So we have 1 gram. And we're being asked to find the mass of copper oxide. Okay, so if we're given mass, you're automatically going to be calculating the molar mass of each compound. So this one is 221.13 grams per mole. And this one is 79.55 grams per mole. I'm only going to calculate the molar masses for the compound I'm given information about and the one I'm asked for. I'm not going to calculate the molar masses of carbon dioxide and water, since they're really just byproducts or spectators in what we're looking for here. Okay, so I know that this is my known because I am able to calculate moles of this. I'm also given information about that. This is my unknown because it's what I'm solving for, or it's what has a question mark. Okay, now for using unit analysis, there's a simple process to be used. So we need to, using our mass of known, convert to moles. Then we need to use our mole ratio to convert from our moles of known to the moles of unknown. and then we're going to find our mass. All right, so this is one conversion factor. The other conversion factor we're going to be using in both cases is our molar mass. So let's get started. We're going to start with the mass of our known, or the given information. So 1 gram. Now we need to use our conversion factor to try and get rid of the unit grams. And we're looking for moles. So this is where we're going to use our mole ratio. And we're going to flip it so that we have 221.13 grams per 1 mole. Remember, we can write the ratios either way. We can always flip them, like 1,000 meters in 1 kilometer, or 1 kilometer equals 1,000 meters. Either or. Okay, now we've canceled out moles, and this was, grams, and we're left with moles of our malachite. All right, that was our known. Now that we're at moles, we get to use our mole ratio. So our mole ratio is unknown over known. So the moles of unknown is the coefficient in front of the unknown. So that will be 2 moles of copper oxide. Now I always like to write my compounds in here so I don't get too confused, because we talk about a lot of moles. All right, all over the moles of my known. So that was my malachite, what I started with. So that was 1 mole of malachite. All right, now once again, we have some unit cancellation there. We got rid of our moles of malachite, and we're left with moles of copper oxide. But that's not what we're asked to solve for. We're asked for mass. So we need to go from moles to mass. All right, so we need to cancel out the moles of copper oxide, and we're looking for mass, which is the unit of grams. And so this is once again a molar mass. However, now it's the molar mass of copper oxide, since now we're on the unknown side, okay, where we have to use information only about the unknown. Oops, unknown. All right, so our molar mass for the unknown was 79.55 grams. Now, as usual, we multiply all the way across the top. So 1 times 1 times 2 times 79.55. Press equals and divide by everything across the bottom. So 221.13 times 1 again. And we should get 0.719 grams. All right. Okay, so second example here. Determine the mass of oxygen required to completely burn 10 grams of propane. So I'm going to go through this one just a little bit quicker because my video seems to be getting a little long. So first things first, I need a balanced chemical equation. So propane is CN. Oh, goodness. We have 10 grams of propane, and it has a molar mass of 44.11 grams per mole. And we're looking for the mass of oxygen gas, which has a molar mass of 32.00 grams per mole. All right. Now, just like our previous example, we're going to go from mass of our known to mass of our unknown through a bunch of steps. So we start with our mass of our known, and we're looking for moles. So I want to try and get grams to cancel and find moles. Grams and moles in the same unit is a molar mass, so 44.11 grams per 1 mole of propane, so C3H8. All right, now we need to get rid of moles of C3H8 and switch to moles of oxygen. So this is our mole ratio, unknown over known. So we're going to get 5 moles of O2 per 1 mole C3H8, and our moles of C3H8 cancel again. We're left with moles of oxygen, but we're asked for mass, so we need to multiply by its molar mass. We need to cancel moles of oxygen and find mass, so this is 32.00 grams per 1 mole. Our moles of oxygen lastly cancel. We're left with only the unit of grams on top, and all the units on the bottom have canceled out, so that looks good. Multiply all the way across the top, so 10 times 1 times 5 times 32. Press enter. Multiply all the way across the bottom, 44.11 times 1 times 1. Press enter and divide those two numbers. We should get 36.3 grams of oxygen. Looks good. Now this was a lot of information, and I want you to take the time to do all the practice problems and understand the process of what you're doing. If you are confused, now is the time to ask for help, because I will expect you to be able to do this for pretty much at least 3, 4 more topics out of this unit. Okay, so it is a big concept. We really need to practice it. Good luck.